I am here at Roy Electronics in northern Italy, and I'm going to share with you now the PCB assembly process as it starts from the breadboard PCBs to the end customers. Roy Electronics have implemented a very advanced Industry 4.0 PCB assembly shop floor. As you can see, there are hardly any operators in this production floor because they have chosen to implement a very high level of automation. This is the shop floor of the future. Let's go have a look. The burr board goes into the laser marking machine. The machine marks a unique serial number which comes from the ERP and reports to the output file that the Valor IoT can then collect the data. The serial number will enable us to track this specific board and know exactly what happened to it. At Roy, the serial numbers are generated by the ERP and are unique to each PCB. The screen printer applies the paste through the stencil. Each job has a different stencil which is planned with Valor process preparation. It must be precise per product and per revision. At this station, we can expect a relatively high rate of defects. It is very sensitive to environment condition, temperature, humidity, time. This is the reason for many tests and inspection after this stage. With Valor Material Management, we can conduct stencil verification by scanning the stencil barcode and reporting the exact stencil and paste we have used. The solder paste inspection machine, referenced as SPI, tests the quality of the printer to verify that everything was printed according to the plan and there is paste only where it should be. The SPI will run the test program and report the findings in a file including pass-fail as well as measurements. This data is later on collected by Valor IoT. Roy has three types of pick-and-place machines: a fast pick-and-place machine, a machine with a camera for small and subtle components when accuracy is highly important, and a very strong machine with high pressure for boards that require force in implementing its components. Having different pick-and-place machines is typical to many manufacturers. It allows for high accuracy and flexibility. Valor process preparation can help in generating the assembly programs. Valor IoT Manufacturing connects to the pick-and-place machine and can collect data regarding machine utilization. Valor Material Management helps manage the material on the machine and replacement of material when it's consumed. At the visual inspection station, operators can validate that the correct components were placed on the board before continuing in the manufacturing process. Valor process preparation can create a documentation which will define for the operator what should be inspected at this stage. Here, the soldering is done. The plan for the oven is referred to as an oven profile. The reflow oven is divided into several chambers. The speed through each chamber can be different, and each chamber can have a different temperature. Valor IoT Manufacturing connects to the reflow oven and receives information regarding the actual temperature and speed of the oven. At this station, we wish to ensure that each component was placed correctly in the right angle and that the soldering is good. Valor process preparation can help us prepare a test program so that the exact location where the pins contact the pads will be examined. At this point, the SMT process is complete. Following the SMT process, we have additional placement technologies such as through-hole and manual assembly. At the through-hole station at Roy, we can see that the through-hole components are placed manually on the PCB, but they are then soldered in a selective soldering oven. There are two methods which are used to perform electrical tests on the PCB. Bed of nails for high volume, which allows for shorter time of testing but requires expensive development of fixtures, or flying probe for high mix, small volume. It takes longer to program the flying probe and run the test, but is much easier to handle new products. Valor process preparation can help plan the fixture of the bed of nail as well as generate a program for the flying probe machine. In addition, Valor IoT will collect data from the different testers, including the different electrical measurement as well as the pass-fail. All Valor manufacturing solutions have been integrated into the Camstar electronics suite. Data is sent to the MES, which now runs the entire process. For large BGA components, we need to check that the pins reach the right layer. These pins are usually behind the component and therefore cannot be tested with AOI machines. In this case, we use an X-ray to take an X-ray image of the PCB and make sure that the connectivity and the soldering is adequate. Now we can actually test the functionality of the completed product. The preference is always to find issues through the different processes and avoid finding defects at the last stage of the functional test. Here, mechanical parts are assembled manually or by a robot. At this point, the product assembly is complete. That's it. The product is ready to be delivered. We can package it and send it to the end customer. The PCB assembly process has been completed. Now that we've learned how PCBs are made, come and join us in leading this industry.
Siemens, ingenuity for life.